If parents who are carriers for a recessive disease have a child affected by the disease, the next 3 children are risk-free. Myth or fact? It's easy to get confused when looking at what diseases are passed on and the likelihood of them being passed. When looking at inheritance, the probability of a dominant characteristic being expressed is 3 to 1. That means if you have 4 siblings, statistically speaking, 3 will show a dominant trait and 1 will show a recessive trait. But that's not always the case. Let's dive into this problem a little further. To start, we can analyze Mendel's first law of segregation. This law states that alternate versions of alleles, one inherited from mother and one inherited from father, can cause variation in inherited characteristics. Each allele inherited is either recessive, wherein the gene is submissive, or dominant, wherein the gene essentially dominates. Within this system, there are 3 possible genotypes, which respectively produce 3 different phenotypes, or physical characteristics. Let's refer to a homozygous dominant gene as capital XX and a homozygous recessive gene as lowercase xx. No matter the genotype of the parents, an offspring will inevitably render a genotype of capital XX, lowercase xx, or capital X, lowercase x, also known as heterozygous carrier. In the case of recessive disorders, an individual will be affected and present phenotypic characteristics of a disorder if and only if their genotype is lowercase xx, homozygous recessive. This means both copies of the gene, one from mom and one from dad, carry the mutation. An individual with a capital XX genotype will always dominate and therefore present no symptoms, while an individual with a capital X, lowercase x genotype will also be asymptomatic, because the capital X dominates, but the lowercase x represents a carrier status. So in this case, they will have the ability to pass the disease on to future offspring. In other words, if both parents are heterozygous, there is a 25% chance that their child will be lowercase xx and have the recessive disease. Let's consider the following example of sickle cell anemia. Firstly, we have to understand that the healthy allele is dominant and sickle cell anemia mutated allele is recessive. That means if an individual has one healthy allele and one allele for sickle cell anemia, they will be healthy and not show a phenotype. This individual will be a disease carrier. Now let's assume both parents are carriers. We can create a Punnett square to show the likelihood of offspring inheriting the disease. As we can see, looking at the potential offspring, there is only a 1 in 4 chance that a child will be homozygous recessive for sickle cell anemia. This means there is a 1 over 4 or 25% chance that each child will be affected by the disease. This 1 over 4 chance is non-relative. It is independent of other children. This is because for each child, the parents' alleles assort randomly, and previous children do not affect this random assortment. For example, if a firstborn child is homozygous recessive and therefore affected, the second and third child could be homozygous recessive as well. Although based on probability that is not likely to happen, it is indeed still possible. Furthermore, we could use the product rule to assess the probability of 2 or more independent events occurring together, or each child inheriting sickle cell anemia. The product rule is done by multiplying the probability of independent events together to determine the likelihood of occurrence. So let's assume a mother and father are planning on having 2 children and they are both carriers of sickle cell anemia. Each child's independent probability of inheriting the disease is 1 in 4, but when multiplied all together, 1 over 4 times 1 over 4, we get a value of 1 over 16. This value of 1 over 16, or 6.25%, represents the probability of both kids inheriting sickle cell anemia. So while it is still unlikely, it is most definitely possible. As can be seen, there is a wide-held misconception that if parents who are carriers for a recessive disease have a child affected by the disease, the next 3 children are risk-free. As explained in this video, this is not the case. Each child born to these parents will have the same chance of being affected by the disease as each consecutive offspring is, independent of previous outcomes.